Welcome to the deep dive. Today, we're zeroing in on a pretty small box that has a massive responsibility. It's the NTI PWR-48V-5V2A external DC power converter. And our mission really is to figure out what this one piece of hardware tells us about the critical environments it's built for.
Yeah, this is a great deep dive because it's all about the engineering trade-offs for, for pure reliability. This converter's job is, at its core, pretty simple. It just has to bridge two worlds.
Okay, two worlds.
It takes a high voltage, high availability input, and we're talking 48 volts DC nominal, and it just steps it down.
Yeah.
Steps it down to that standard plus 5 volts DC that, most network devices need to run.
Right, okay, so let's unpack that step-down function a bit. The source material shows a really wide input range. It's something like 36 volts all the way up to 72.
It is. It's built to handle major fluctuations, and that regulated 5-volt output can handle a 2-amp load.
So why 48 volts? That feels like a very specific standard.
It's the key context. It's a telecom legacy. Power is often supplied as negative 48 volts DC. And what's fascinating there is that the negative potential actually helps reduce galvanic corrosion on all the copper wiring. So it's about longevity.
Ah, okay. So that system-level thinking already starts to explain the price tag here. But speaking of specs, the efficiency is listed as 80%, give or take 5%. I mean, in the world of modern converters, 80% isn't exactly groundbreaking, is it?
That's a great question. No, it's not. And what you're seeing there is a deliberate sacrifice. You're trading a few percentage points of efficiency for extreme tolerance, for rugged components.
So simpler is better in this case.
Simpler is more reliable. When failure means a whole cell tower goes dark, you use parts that are less likely to fail under stress, even if they aren't the absolute most efficient.
And this is where it gets really interesting, especially for anyone working in the field. The device is designed to accept positive or negative polarity input.
That right there is the crucial nugget. Think about it. A technician in a telecom cabinet can't always know the specific power setup they're plugging into.
Right. They could be dealing with positive ground, negative ground.
Or something else entirely. This little box just figures it out internally and delivers that clean 5-volt power no matter what. That flexibility literally prevents hardware from getting fried.
Okay, so if the input is that flexible, how rugged is the rest of the package? The input side uses a 3-pole detachable screw terminal.
And that just screams industrial reliability. You can't have a regular barrel connector just wiggling loose in a cabinet that might be, rattling from nearby machinery. This is for vibration resistance.
But then on the output side, it uses a very standard 2.1 by 5.5 millimeter DC power jack. Doesn't that sort of become the weak link in the chain?
It does, in a way, but it has to because the NTI products it's powering use that standard connector. The real engineering muscles on the conversion and the input side. And they even include that 3-foot female-to-female cable you need for a lot of rack-mounted gear.
Let's get to the metrics that really justify the cost here. The durability. The operating temperature range just, well, it's staggering. Minus 13 to 158 degrees Fahrenheit.
It's huge, isn't it? And what that tells you is they're not using standard components. You're talking solid polymer capacitors, specialized thermal design. You're paying for this thing to work just as well in a desert communications shack as it does in the Arctic.
But the number that really stands out is the MTBF, the mean time between failures. It's listed as 120,636 hours.
Which is, what, over 13 years of continuous operation, statistically?
13 years.
Yeah. And that 13-year number isn't just about the hardware lasting a long time. It's about avoiding what they call truck rolls. You're avoiding sending a highly paid engineer out to some remote location just to swap a tiny power converter. Avoiding just one of those trips pays for this device many times over.
And, of course, for anyone who needs to actually buy this for, let's say, a global deployment, it has all the stamps you'd expect. CE, OHS, and it's TAA compliant.
Yeah.
So it really is that perfect bridge. It lets you plug standard IT gear into these hardened industrial power systems.
It is. It's a fundamental problem solver in a box. So I guess the thing to think about is this. When a small component like this can run for over a decade, surviving these insane temperature swings and any polarity you throw at it, what does that tell you about the real hidden cost of equipment failure in that 48-volt world? The price of reliability is almost never about the hardware itself. It's about preventing lost revenue or, even ensuring public safety.